With Android Vitals, you identify performance issues in your app. Android Vitals provides information about battery use, stability, rendering, app startup time, and permission request. In this DevByte, I'm going to show you how to address the battery-related issues of stuck partial wake locks and excessive wake-ups. With the wake locks API, you keep a device from entering deep sleep, and as a result, prevent it from conserving the battery. A stuck wake lock occurs when you acquire a wake lock but never release it, so the device keeps the CPU running and drains the battery. What's the best way to avoid stuck partial wake locks? A simple solution is to stop using them. In modern Android, there's rarely a situation where you have to use a wake lock. For example, take an activity. Whenever someone is using your app and you want to keep the screen on, instead of setting a wake lock, use a flag on the window that will tell the system to keep the screen on. As a bonus, there is no way to leak the flag. For services, if you schedule them as job instead of using custom free-running services, the job scheduler holds and releases the wake lock for you. Similarly, if you use the alarm manager to schedule an alarm in broadcast receiver, there will be a wake lock held for you for the duration of the on-receive. If you don't use wake locks, another benefit is that you don't need to include a permission request in your manifest. But if you must use a wake lock, always use a partial wake lock. The other types of wake locks are deprecated in the latest version of Android. Always set a timeout value in wake lock acquire so that the system will clean up the wake lock after the timeout expires. Also, give your wake lock a static descriptive tag without counters, or even worse, private or sensitive information. Why? Because Android Vitals will report on the wake lock by name, making it easier for you to debug issues. Finally, remember to code defensively. Assume that things can go wrong and use try and finally blocks to make sure that you release wake locks as soon as you are done with them. The second half of the Android Vitals battery equation is excessive wake-ups. The main contributor to excessive wake-ups is the use of the old Alarm Manager API, specifically the wake-up type of alarms. When working with Alarm Manager, there are 3 R's that you should consider. Remove calls to wake-up alarms, if possible, reduce the frequency if you have to use a wake-up alarms, and replace your alarm with other APIs. When it comes to replacing, if the wake-ups is for something happening on your server, send it as a push message using Firebase Cloud Messaging. For activity triggered on the device, use one of the job scheduling API, such as Work Manager, Job Scheduler, or Sync Manager. This intelligent job scheduling mechanism gives you a lot for free, such as automatic wake off and retry if your job fails for any reason. Criteria-based scheduling, so you can wake up the device only when it has a network connection or is charging. Those and standby compliance and automatic wake lock handling. Regardless of whether Android Vitals is telling you there is a battery problem in your app or not, remember to use the Android Studio Energy Profiler. With this tool, you can debug any kind of wake lock problems and get details about alarms and job scheduler in your app. People will quickly remove your app if they encounter battery problems after installing it. Following the guidelines in this video, you should be able to avoid battery problems in the first place. But if you don't, Android Vitals will quickly highlight them for you. To find out more about Android Vitals and the ways of addressing battery problems, check the resources listed in the video description. And remember, to find out about this and other features in the Play console and get tips to grow your app or games business, you can use the Playbook app available on Google Play. Thanks for watching.